Okay, guys, welcome back. Let's see. We cover a little bit of deep learning with neural networks. Then we move to unsupervised learning. We talk about clusters, and I talk a little bit about text mining. Text mining with the approach of unsupervised. Text mining with the approach of creating topics, clusters of words. Now, something that I would like to do is to move to supervised learning. Supervised learning, the easy one. The one that you have the data and also you have the expected output, and the only thing that you want to do is to create kind of a function that map one to the other, so you can have this model to classify things. In particular, in order to connect the ideas, we're going to work with classification, separate from text mining. But the question right now that we have this understanding of text mining is, do you think that we can do text mining, work with that data that are documents, and work with classification instead of clusters? And hopefully you are thinking like, yeah, why not? So far, we apply clustering, unsupervised learning to documents. And our goal was to literally try to create groups for the documents. What if, by any chance, we have documents and we know a label or a class for a group of documents, and therefore we want to know if a new document belongs to that classification or another one according with the previous model that we create, right? Classification with documents. I want to move to classification, but since we're working with documents, let's talk about classification, supervised learning with documents, and in particular, let's review the classical example for this. And the classical example for this is you want to classify an email in spam or not spam. Two classes, two groups. You already have them defined. You can have samples of each category. And the only thing that you want to do is to create this classification of a new document in one on the other category. Makes sense? Now, that is the connection that I want to do. Finish with text mining, but start with classification. Now, talking about classification, we're moving from this part and that part, the things in blue, to the orange. Classification is one of the branches of supervised learning together with regression. Let's start with the easy one. And moreover, in the easy one, you notice that there are a lot of names at the top, a lot of different algorithms that we can review. In particular, I would like to take a look to support vector machines, Bayesian networks, and trees. Those three, something that we can do, in particular trees, because they are going to help us to move at the end, I think, to random forest and cover assembly methods. Good, kind of our plan. Now, classification, supervised learning, and in particular for spam detection. We need to work with classification and we need to work with supervised learning. Supervised learning, a definition that you already have from the week 1, week 2. We have the data, but also we have the labels. And with that, we can work. For the text mining with this supervised approach, I showed you this slide weeks ago. We work with some of those cases. I want to work here. The last thing that I mentioned when we start with text mining, the spam, 2 categories. It should be very, very simple. We have documents, we have samples, and they are either spam or not. And then I can create an algorithm for that, a model. Now, before we talk about text mining, before what we review as an algorithm for the model was this LDA. What we review was this method that works with probabilities and is not working or is not looking for classifying something, is just trying to find probabilities for topics. So I want to be clear now that everybody's here. Text mining, before, unsupervised, before, LDA, this slide, today, supervised, and something is going to happen. Something that is different from what we have before. Now, help me. What we need to do in order to move text mining to a supervised effort. Number one, I already mentioned, is about we need the labels. And I think it's something that we can have. In fact, if you remember, even with the unsupervised approach, even with this news, we have samples of different news in different categories, in different folders. So we already have the labels there, but we choose not to use them because we want to do unsupervised before for the news. Now, if we want to do supervised, we need the labels, and I think having the labels is easy. Having a bunch of emails that are spam and having a bunch of emails that are not spam could not be so complicated. Good. Now, step two. What else do we need?
The words that constitute a topic.
The what?
The words that constitute a topic.
Okay, the words. That is going to be a key idea. I want to be sure that we remember this. In the past, with this approach for LDA, do you remember that here we needed the words? We used the words. But what we did was for every single word in a loop that was inside of another loop, we take the word and we calculate the probability of that word to be in a particular topic, and therefore we calculate the probability of a particular document to belong to a particular topic also. Do you remember that basically what we did was read every single word in every single document and then play with probabilities, right? If we want to move to a supervised approach, what we need is a table. Yes, one of the things is the label. Yes, one of the things is going to be here, spam, non-spam, if we want to play with this example. But the other thing that we need to care is about our inputs. Our inputs, we are still working with text, right? So I am sure that you're going to agree with me that working with text, what we are going to need is the words. And the words are going to be our features. Moreover, the tokens, right? We move the words to tokens. Each word is going to be like one column. The only new thing, the only thing that we need to consider is now we are not going to play with probabilities of the word being the document, the word being the topic. We don't care about it. We need something more concrete here, and here, and here, and here. And every single one of these rows is probably a document, right? Documents, our samples, the columns, our features, the words, and there is an intersection here. Help me, what do we put in those rectangles? Can you agree with the number? Moreover, can you agree that basically what we need is a counter of how many times a particular word is in a particular document? The fingerprint for the document is going to be a group of numbers, a vector of numbers. And that vector of numbers is literally going to represent the number of words in the document and how many times a particular word, that is one feature, one token, is there. The order of the numbers in the vector is going to represent which word I am talking about. Again, before with unsupervised, before with the LDA, we do not need the counter. We never count how many times a word was there. What we did was to calculate the probabilities of the document to be in a particular topic. And obviously, more times the word was in the document, higher the probability, or the probability of being a particular topic increased, because that word belonged to the same topic. But we were talking about probabilities and we were matching the words to the topics. Remember these groups. We never count how many times a word was in the document. We don't care about it. Yeah, more times the word is in the document, there is an impact in the probability, obviously. But this data, this kind of specific thing was not there. Can we get these numbers? Yes. I think it's easy than the probabilities. If I have this input, these numbers, these vectors, with these labels, the next step is to find a function that map this output with this input. And to create that function, a lot of options. That is easy. Clear. Good. So if we understand the approach, then we can work. Let's start with the tool. Do you think that by any chance there is a library that we can use to make classification of documents? For sure, yes. The other question is, do you think that this library that we use for unsupervised text mining, Mallet, can also work maybe for a supervised approach? Like, yeah, obviously, if the library is for text mining and they implement one that look to be more harder, why not the other? Yeah, classification of text documents. A tool that you can use, again, Mallet. And what you need to work with that is the tool and basically 2 jar files that you need to add in your project. Easy, right? You already have it. Okay, next. Let's do a project for you to practice. Before in unsupervised, I asked you to play with the news. Now in supervised, let's play with example of email, spam. Spam. Do you think that there is a data set that we can reuse with spam email? For sure. As you can notice, there are data sets for everything that you want to explore. You can create your own data sets, but if you are going to learn, it is better to start with something standard and then you can move to your own data. Spam emails. You can get this data set from this address and just maybe, did you know a guy with that last name? And that is the name, yes. Okay, I am taking the data set from his course. You're going to notice. You can use it, it's public. Data set. This is a 1 line, right? So I just put 3 lines, but you can like 1 URL. And you can get this particular file. Be careful. The guy is using the data set for 2 different things. Number 1, the one that we're going to do here, text mining. Number 2, to check Bayesian networks. There are 2 data sets. One is preprocessed, the other is not. I am asking you to use the one that is not preprocessed. And that is this name. And it's a zip file. What are you going to get in the zip file? 350 samples for training about spam email and exactly the same non-spam email. So 700 samples of emails for testing. the data set is already split in testing and training. So you don't need to do that. And you have 130 samples for the spam and the equivalent for the non-spam. So those are your numbers. Good, right? Again, you can use your own email. Let's start with something that is already there. If you open this data set, you're going to notice they are not full emails. The documents, the text files are already kind of cleaned. A lot of words are not there. If you try to read the document, it's like, okay, this was an email in some point, but words have been removed because, as remember, not all the words are useful to classify things, and also you need to keep the privacy of the people that wrote those emails. So text files are related with emails, not exactly full emails. When you get the data set, the next thing that you need to do is to put the data set inside of your program, right? Do you remember what we did to put the data set for the news inside of your program? Hopefully by now you are familiar with the class that you need to use in order to get the data from the files. Do you remember the name? That one? Moreover, you are working or you work in your quiz, this homework that I asked you to do, and you remember that you use maybe, hopefully, 2 parameters for the constructor of that class. You remember that you use a parameter to specify the path of your data set for the BBC News, and hopefully you use another parameter to specify which are the files that you want to read, the text files. However, I am sure that you remember that the first time that we talked about this class and was this slide, we mentioned that you could use 3 parameters. And do you remember the last parameter? The class. Why? Because the library allows you to do supervised and unsupervised. If you want to do supervised classification, you need the labels. But if not, like we did before, you do not need the labels. Clip. Now, a common thing to do, something that we reviewed before, the last one is the label. And an easy way to read the label for a group of files is to put the files all in the same directory and therefore use as a label the name of the directory in which those files exist. So you can imagine that something that I can do is to put all the samples that are spam in a folder called spam, and that is going to be the class for those files, and the others in another folder called non-spam or others or whatever, and that is going to be the name for that particular class. And the only thing that I need to do is to tell my file iterator object with a 3rd parameter that the name of the directory is the class for that particular entry, right? Easy. Easy. So are you telling me that right now I have this program? This is the source code that I shared with you before, the one that you use for your homework. And in the line 15 to 18, that is what you have, hopefully. 2 parameters, data, BBC, and your filter. Are you asking me to change those lines in order to add 1 parameter extra? Something like this. Different folder. Now I am going to use emails. Parameter number 3, last directory. If you remember, last directories, doesn't matter how many directories do you have in your path. The last one, the one in which the file is inside, is the name that I am going to use as a label. Whatever name you put there. In particular, what I am going to use, and up to you, if you want to run my program, you need to replicate the same thing. But I take the data set from the web page, and what I did was to order the data set. You notice the name of the data set at the top of my window in 2 folders. I put the testing data set here and the training here, And inside of the testing, spam and not spam. And inside of the training, spam and not spam. And inside the files. If you have something like that, I am going to start by reading the data for training. Are you going to read the data for testing in another part? Yes, I am going to read that data in a different part. Right now, my goal is to train a model. So right now, I want to read the data inside of my folder train. And inside of that, I have two folders, spam, non-spam. Those are going to be the labels because all the files are inside of those two. Clear? Good. So next, after I do this, do you remember the next part? If you're playing with this text mining, one thing is to read the data, read the paths of all your files. Next, you establish a pre-processing pipeline. And the pre-processing pipeline was this chain of responsibilities pipeline pattern in which basically you add pipes to do different things. So far, what you have in your framework is all of this. This is, again, the software that I shared with you before, and I am sure that you use all of this, or at least you know what all of those do. Good? Do you think that we need something new for the supervised approach? Well, number one, do you think that those can help us for the supervised approach? Char set, the tokens, and so on. I agree with that. It's like all that thing that we did for the unsupervised, I am confident that they can help us also for the supervised. At least they do not hurt. We need something else.
Evaluate the outputs, like the labels and the inputs.
Okay, we need two things. One thing is we need to take care of the label. Because one thing is we are reading the labels in the file iterator, but that is used for reading. But we need to store the label in some place. So the label, take care of the label is one thing that for sure we need. And you know what? It's something that we can put in the pipe. So one thing. Second thing, what about this number here? Who is going to put this number there? Because remember, before, we do not need this number. But now it's something extra. We need the number, right? Someone needs to count the words and create this input with the numbers. So can you agree that there are two things new that we need for the supervised classification approach? Data in our input. Okay, this is your pipeline right now. What about that? Exactly the same plus 2 lines. Two more pipes. What you already have plus 2, the blue lines. Help me, can you guess what is happening in those lines 29 and 30? Feature sequence to feature vector. We have before this token sequence to feature vector. Token sequence to feature sequence. The features are the columns, the tokens are the tokens. So from the tokens to the columns. Now we have a new one. Feature sequence to feature vector. What is that? What is a vector? An array with numbers. Oh, a vector, a collection of elements. A dynamic array, the representation. What do I need in a dynamic array? These are my features, and for all of them, I need a vector. The row without the label is a vector of numbers. Number of what? Counters of how many words do I have. That line, feature sequence to feature vector, is our friend that is going to put the number here. It's part of the pipeline. For each input, keep a counter. At the end, those numbers are going to be important. Parameters. No, do not need parameters. The method know what to do, count the words in all the documents and report everything. Good. The next one, can you guess what is going to happen with target to label? Who is the label, or what we call labels? The names of the categories. Who is the target? All these guys. For every single row here, add, put a label. Target, map with a label. Include this in your input. Those two guys, taking care of the labels and counting the words is the only thing that you need to add in your pipelines, and now you can work with a supervised approach, classification. Not this. The pipeline is not doing anything. It's just collecting data, providing some kind of format or structure for your data, period. Now you need a counter, vector with numbers. Now you need the label. You have instructions for that, 2 instructions, done. Everything else still works. As you can notice, you create your pipe list. You use the pipe list to create a serial pipes, and then you apply the pipes to every single instance, and that is going to give you your data. Nothing new. Clear? Good. So labels, counters, 1 parameter extra for the file iterator, 2 more pipes, and what you are going to have is this, that is the same thing that we put in the whiteboard, a table with numbers, counters, and your labels. Now, with this, now we can think about classification. I mean, right now, you can forget that your inputs are text documents. And with this in your mind, this can be the same data that you use for the iris dataset with the flowers or any other thing. What you have right now is this Excel spreadsheet with numbers, columns, and one of the columns is the output. And the others are just numbers that represent something. And to be clear, you do not care about what they represent. Well, the algorithms do not care. Later, you care about interpreting the results. But right now, with this input, your next step is, okay, now we can do classification. And to do classification, we have several different options of algorithms. Several different options, yes? Yeah, really. Remember, supervised learning, classification. And at the top, we can talk about bias networks, we can talk about SVM, we can talk about decision trees, and so on, just to mention some of them. Something that we need to do is to review them, because it could be a good idea to identify in which cases I use one or the other. However, something that I am sure by now you are expecting is it should be a class for each of them. Right. So if right now I tell you, let's wait for the next week to review the details, and right now just to finish the problem, to think about, okay, I have input for a classification problem, let's use one of those as a classification model, and then I can have finished my spam recognition program. And later I care about this black box here next week to see what is inside. Clear? Okay, let's play in that direction. And in particular, let's start with that one. Bayesian network. I just give you the name, something that is coming, but right now it's like I am going to do classification, and I am going to do classification using this mallet library. And in particular, someone told me that bias is a good approach, and therefore I want to use it, or I want to try. I do a little bit of research, and my research is as follows. I need a model. My model is going to be supervised. Because it's going to be supervised, I am going to run classification. And you know what? The algorithms that do classification are called classifiers. Classifiers, yes, in particular in the mallet, they are these classes. A class classifier, and my class classifier is going to be using different approaches, or can use different approaches. Different approaches, yes, the different algorithms that I show you. And what I want in particular is a classifier, but the classifier that I want is this one that follow the bias approach. So I want to use that one in particular. Create a class, create an object from a class. Number one, the classifier algorithm, a new object, classifier training or whatever. Did you notice what it is? New. Polymorphic behavior, right? You can imagine that this classifier trainer is the parent of a strategy algorithm. And basically you have one that is this bias. That is the one that I am going to use, but I can create an object here. Really only to show you that these three exist. You can put the same class here. Anyway, you have your object that represents your algorithm. And the next thing is, okay, let's work with that guy. And let's put the guy to work. And in particular, let's put the guy to work with some data, the instances that we read before. Remember, we have these class instances. We have all these instances that are basically the input data after the data passed for the pipeline, and we have it. That was the input that before we used for the LDA algorithm. Now, that input is for my classifier. In this particular case, for the bias classifier. And that one, the train, that is also a method that is becoming common, is going to return some results. And so those results are going to be the ones that I want to work with, is my model. Clear? So again, previously, here you have the instances. The instances are your data from the file iterator that pass through the pipes. Instances, all your data after you pass the pipes. Here in your model, those instances are your parameter for train, the method in the classifier. Your classifier, in this particular case, an object for bias training. Good? Done. A new class, a new parameter, two new pipes, and we have a model that was created with supervised learning. Supervised learning, in particular, for some reason, hopefully a good one, was using this. We need to review what happened there, because right now this train method is kind of our black box. We need to check what happened inside. However, something happened, and that something happened, and now give me a function to map the data to from the input to the output. Next step, something that you want to do for sure is, I think at this point, you want to evaluate your model, right? Because yeah, we need to review what's happening inside, but before looking inside, probably you want to know how good or bad that model is right now. How good or bad the model is. Help me. Thinking about classification, thinking about supervised learning, what kind of measures we can use for the evaluation?
Confusion matrix.
Can you agree that we can go back to the confusion metric? We forget the confusion metric with unsupervised because we do not know the correct answers. But now that we have back the correct answers, basically the evaluation is again back to what we did at the beginning about comparing how many times the result is equal to the one that I know that is the correct and how many times it's not. Moreover, I am not only back to being able to create the confusion metric, but more important, I can calculate now, again, F1 score. recall, and precision. Obviously, accuracy was there even for the unsupervised, but something that I can do now is to evaluate not only the full model accuracy, like errors and no errors, that is something that I asked you to do in some point, but we can go back to evaluate the classification of every single category, because that is what you do with the precision and the recall, right? F1 score. Those are the values that I am thinking we need to evaluate our classification model. Yes? Okay, so let's see. Blue lines, things that are new. Let's see if we get the idea of what is happening. Now, we have a model, right? We create a model with the training data. We want to do evaluation. Evaluation is all about the testing data and using the model with the testing data and measure these confusion metrics and all the metrics that we reviewed before, right? By now, it's exactly the same process again and again and again, doesn't matter what we are doing. Help me, lines 39 to 43, what is happening there? Looks like 40 to 43 is something that we can review first. 40 to 43. A file iterator. I am reading files. Did you notice the parameters? Looks like now I am reading the training data, hopefully. The folder test in data. Do you remember that before we read the data in the training set in a different folder? So now I am reading these 130 files for each category. Really, I do not care about how many files there are. I just pad the top of the tree, the folder, and the iterator is going to read everything there. So now I am reading the files in the testing data set. The same filter, txt files. Again, the label, they are supervised learning, they have a label. The label again is the name of the folder. So again, I have this spam and non-spam in the testing data set. Yeah, do you remember the picture in which I show you my folder, testing and training, and both have spam, non-spam, and then the file, right? Good. I have a file iterator with new files. What I have at the top there, that instance list. My instance, right? My instance. Did you notice the parameter? Do you remember what is the parameter for my instance? Do you remember that the parameter is the pipeline that I am going to use? Yes or no? Instance list. I want to go back here and I would like to check for instance list. And if you notice instance list here, the parameter is the pipeline, right? Okay, what is happening in the Nexus code, the one that I am using for evaluation? Which pipeline I am using? Yeah, you have two options, guys. You can put there pipeline again, because you have it. It's your object in your program. But also, and just to show you that second option, is like you can ask your model, remember the model now is the classifier. Hey, can you tell me your pipeline? Because I want to use the same pipeline that you use for the training, now for the testing data. You can use here, again, the object that you have. But by having that line, the 39, you are sure that the same pipeline that happened with the training is going to happen with the testing. And I am sure that is something that you want to be very, very sure that happened, right? The same preprocessed method for the data. Good. So the iterator, your pipeline, 44. I think this is very, 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 very familiar. In the instances and the data from the iterator passing through the pipeline. If you check the source code, 44 to 39 is a copy paste of the same source code that you used before for the training data, with the exception of the pipeline, that you are not creating the pipeline, but reusing the pipeline. Clear? Okay, now, this was only to load the data. Next step, do you remember what is the next thing that we usually do after we load the training data? There is always a class evaluation or evaluate or something like that, right? A class that have the methods to help us with the evaluation. Well, your new class, the class for the evaluation. And the class for the evaluation, you're going to create an object. And that object is going to need parameters. And in particular, the most important parameter there, your model, obviously, is a class evaluator. The class evaluator works with different models, can evaluate different things. You pass as a parameter the model. The model is going to be used to calculate results. And those results are going to be compared with the data that you already have. So the second parameter that you need is that data. The classifier that you create before in my previous slide, and the data, the instances, which instances, the instances that you have for testing. I call this, and you can imagine that inside of the constructor of that object, something that is going to happen is this class is going to take my model and line by line in the data is going to pass that data to the model, and the model is going to return the result, and this guy is going to compare this result that the model is reporting with the good one that this guy had, because I pass all this table with labels and data. All that is going to happen inside. And again, you can imagine this loop running there. And inside, this guy is going to be counting the number of errors and counting the number of correct predictions. And at the end, you can use this guy, this object, and ask for the results. Ask for the results. Getters. Getters of what? Get recall, get precision, get F1 score. Give me the results. Easy, right? Question, did you notice that I have one parameter there for get recall, get precision, and get F1 score? Tell me, what is the meaning of those ones in the recall and precision? The what?
Last label index.
Yes, the label. Do you remember that I have spam and non-spam, right? And do you remember that recall and precision is something that you calculate per class? Remember, per row and column in the confusion metric. So I am using the number one. I am sure that you can agree that the other possible parameter is the number 0. And I am sure that you can agree that if you put a number 2, 3, 4, 100, you're going to receive an error. Because in this particular example, I only have 2 classes, spam or not. Question, how do I know that the 0 is spam or that the 0 is non-spam? And how I know that the other is the opposite? Is which number corresponds to which class?
We use get F1 spam.
Well, I am going to talk about this one in a minute. Let's hear. How do I know which one is 0, which one is 1?
Alphabetical order.
The what?
Alphabetical order.
The order of what? That is true. Let me go back to this one here. You're going to read the file, right? And you're going to use the folders and the label. Which is the first label that is going to be created? Which is the first folder name that the system is going to read? Non-spam. And therefore, that one, just because it's the first one that I read, is going to become the class 0. The name is non-spam, the name of the folder. The index is 0 because it's the first one that I read. And therefore, the spam is going to be the second one, and it's going to be the number 1, just in the order in which I get it. What is the order? The alphabetical order, because when I read the file iterator, that is the order that I follow for my inputs. So yeah, non-spam is 0, spam is 1, the order of the reading. Now, going back to the source code. You have getters for recall, precision, and F1, and you can pass as a parameter, even here, the number 1 or the number 0. However, you also have getters in which, instead of passing as a parameter the index, you can pass as a parameter the name of the label. You need to be careful because remember, the name of the label should match identically the name of the label that you are using. So if you use non-spam and you put any underscore or things like that, that class do not have entries, right? So it's kind of risky to use the names. You're going to find a lot of source code that use the numbers. The only thing is you need to remember which number match. But if you want to use the names, I give you this example with F1. Professor, why this one have the names and the other the numbers? Just because. Put the number 1 there and it's going to work, or move the others to the names. I prefer you to use the numbers, really is more safe. Anyway, numbers or letters, and you can get the precision and the recall F1 score for your class. Good? Clear? So what is going to happen if I run this program? As you notice, I read 2 groups of data, I create a model, I create an evaluator, I run the evaluator with the testing data, and the only thing that I am reporting right now is the output, those 3 numbers. When you run my program, hopefully you do it before our next lecture, something that you are going to have is this output. The only thing that the system is calculating is the numbers. All the text is something that I print. If you remember the print instruction that I had. Even the spam between the apostrophes is something that I put there, not the system. Help me, those numbers, going back to our lecture about metrics, precision, recall, and so on, this is a good model or not?
Pretty good.
Or is a bad one or a very bad one? Or I could be agree with this. It's like, wow, 97, 96. We have this idea of 95 like a threshold, right? So like, really, you're giving me 96, kind of a little bit above with this recognition of spam? Yeah. Clear. Guys, if you go to the web page from which you get the data set, you can read the story about the data set, this problem of spam recognition, this use of classificators, in particular bias with text from the emails. It was the first approach that, in particular, Mozilla uses to identify spam. I am talking about 20 years ago, but still was the first approach. It's obviously not what you do today. Today we have better things to do, but still, in some point was the 20 years ago. Right? Anyway, it works, and it works kind of okay. Remember, 95 was our minimum. This 96 is kind of good, but obviously you can have things that perform better. And one reason because this perform good is, again, review the data set and you will notice that they are not real emails. A lot of pre-processing was done in the files that you are using as an input. So a lot of words and things were eliminated, and all of that obviously support the creation of the model. Models and the technique that you select for the model is important, for sure, but the cleaning of your data is also as important as the algorithm that you select. Cleaning the data, working with good data is critical for getting a good result. And we are not talking, or I haven't talked about cleaning the data as a deep thing. I am mostly asking you to work with real data for your homework and other things. And hopefully you are noticing that when you work with your own data, and if you didn't clean your own data, the results that you get are not exactly, not even close to good. But again, my goal is for you to know the algorithms, not to solve any particular problem. So cleaning the data is kind of something that should happen before you start working with the models. Makes sense? Clear. So here, if I get that thing, and the big picture is like this, I do not expect that you read this, but this is the source code that you can copy paste, and you should be able to run in your own computer the model, the classificator for the spam data set that you get from the internet. So as you can notice, very small source code. Why? Because everything is inside of the black box. The black box, the classificator. The only thing that I show you is how to transform text documents into a data set that you can use for classification. The real topic here that we need to start talking about is, okay, tell me more about the classification algorithms, how they work, what is inside of this box, or here inside of the object that is the classificator. Good. 3 questions. Now, what is going to happen? Guys, Mallet have classificators. This one, for instance, in particular because they work with text documents. So the library have implementation of some classificators that we can use. We do not need to have another library in order to do classification if we already have this library that is helping me with the input of the data. But do you remember the other libraries that we used before for clustering? Do you remember that one? And hopefully you have the opportunity to play with the graphical user interface. And there were this tab with clustering, that was the one that we use. But also you have a tab for classification. And moreover, if you explore a little bit, there were several options there for classification, including this bias. Oh, right now we have 2 libraries, and both implement algorithms for classification. The only thing that we need to know is when to use one particular algorithm or another one. Right now, you notice, for some reason, unknown reason, right, so far, next week we are going to talk about it, but it looks like we select this one, the bias, and this one gives us a pretty good result. Again, above 95. So I am kind of curious about this guy. Like, it looks like he's a good guy. Yeah, in fact, it is. But we need to talk about it. So far, good. Now, something that I want to do in our final weeks, because we are almost done here, but in the final weeks, starting next week, number 1, I want to talk about this one. This guy is a good guy. We need to talk about him. The bias. I want to talk about at least 1 other or 2 other classificators. Classificators are easy, really. Well, hopefully. The last one that I want to cover is decision trees, because after we cover decision trees, I want to move to random forest. Yeah, you have trees, and then you can create forests. And if I mention random forest, that probably is going to be our last topic. I am sure that you can make the map between the idea of if we're going to review trees, then several trees can make a forest, so done. I want to ask you, why random? And probably the question is, have we used random before for something? Hopefully, at this point, you notice that every single time that we have no idea about what to do, what values to use, how to start, the solution is random. And if we're going to create a forest, it's because we have no idea what tree do we want. So let's create a random forest, a group of trees with random things. And that is going to be our assembly method example. Good. So classificators and the assembly method, random forest, used to give you the idea. We're going to finish at the top there with decision trees, SVM, bias, and then assembly methods. And the only one that I am going to cover is bugging with random forest. That is my plan for the last lectures. If we have time, I do a full review in the last lecture, April 28. And after that, your final exam in the full week of May, and we are done. Yes, I know I need to finish grading your midterms. I know. You're going to have grades during the weekend, hopefully. So if my plan is next week to return your papers, you're going to have your papers. As usual, I am going to digitalize the papers, so I have a copy and I return the original to you. Good? Okay, guys, I am going to stop here. Next week, I start with bias and explanation. Thank you.